Bismillahirrahmanirrahim. This is part E of lecture 3 on Descriptive Statistics and Islamic Approach. Lecture 3 is about studying histograms. In this portion, we will study the effect of varying the bin size on the shape of the histogram and the information that we can obtain from studying the histogram. First, let me start with some general remarks. We have a mass of data, complex, difficult to understand. And there are many ways to simplify the data to try to understand it. One of the ways is to construct a statistical model. And models often take the form of data distributions. And this data distribution is best described by a histogram, which is a picture of the data. But the question of what is the best model for the data is a wrong question, because the data is primary and models are just means to understand the data. There may be many different models which clarify for us different aspects of the data. It is not that there is one true model. This we will understand in the context of our study of histograms by looking at different bin sizes which lead to different types of histograms and different types of distributions. The question of which one is the right histogram is not the correct one. Each histogram conveys to us some information which is different from the other types of information, and all of them are valuable in understanding the data. If we look at the histogram for 2018 life expectancy for 190 countries, this is 190 data points. The Excel has a built-in histogram, and that is displayed in this slide. This goes from a minimum of 52.8 to a maximum of 85.0. There are 7 bins, and the size of each bin is about 4.6 years. So this gives us some idea about the shape of the data. We see that in the top 3 bins we have the largest amount of countries. The bottom 4 bins are much smaller, and the highest bin is somewhere in the middle between 71 and 75. So this is the category which has the largest number of countries in it. Now we will consider what happens when there are more bins and when there are less bins, and how much information we get. The coarsest histogram is the one in which there is only one bin. All of the countries belong to the same bin. So this just goes from the minimum to the maximum, and from this we learn the range. The age lifespan varies from 52.8 to 84.9, and all of the countries are in this one bin, and there are 190 of them. When we go to 2 bins, the age range is split in 1/2, and we see that the data is not symmetric. 135 countries belong to the upper bin, which is from 68.8 to 84.9, and only 55 countries are in the first bin, the lower bin, from 52.8 to 60.8. So this means that the life expectancies are not symmetric. There is a skew in this data, and a normal distribution would not be the right model for this graph. The 3-bin histogram divides the countries into 3 categories. The lowest life expectancy countries are from 52.8 to 63.5. The middle range goes from 63.5 to 74, and the top range is in 74 to 85. Now the surprising thing about this is that the largest number of countries are in the best category, and the low life expectancy countries are the fewest, the 27. Why is this surprising? For that we have to look at the next slide. If you look at the same division of countries into 3 pieces by GNP, you see that the top category has very few countries, the middle has even very small number, and the bottom third has the largest numbers of countries, with 160 countries. So what this shows is that even countries with the bottom third income can achieve very high life expectancies. What this means is that one doesn't need a high GNP per capita to take measures which will increase the life expectancy for the population. There must be cheap and simple measures available for substantially and significantly lowering mortality rates, which everybody can do. So it's not a question of having enough money to lower mortality. It's a question of doing the right things, or actually caring about the people and making the right policies. The 4-bin histogram divides up the countries into 4 categories, and in this time we see that the modal bin, the one with the highest number of countries, goes from 68.8 to 76.9. There are 75 countries in this bin. The next highest category is the highest rank from 77 to 85. This has 59 countries, which is still quite a lot. So what this suggests is that easy to get life expectancy up to about 75, and then going beyond that in the 80s is a bit more difficult. To get a better idea, we need to look carefully at the mortality rates in each age group and see where there is room for improvement. Where is the greatest difference between the low LE countries and the high ones? Because the greatest gap is the one where one has the most room to work, most potential to improve. As we keep on increasing the number of bins, we get more and more finer, more detailed information about the pattern of the countries, the pattern of the life expectancy within the countries. So in the 5-bin histogram, we have a single mode between 72 and 78. At 6 bins, we have a smooth staircase pattern. Each of the bins contain increasing number of countries up till the next to last one, which is the modal bin, and after that there is a sharp fall off. If we wanted to classify countries by life expectancies, this bin shows that this is a natural classification which breaks up the countries fairly smoothly. The built-in default for this data has 7 bins in it, and in this we see that the modal value occurs between 71.2 and 75.5, and this has 47 countries. After that, the number of countries started declining, so this gives us some information about the range of life expectancies in where the largest number of countries fall. When we add another bin, we get 8 bins, and this suggests, looking at this, that there are 2 types of countries. The low ones have their own mode and pattern and classification, and the 4 highest bins all belong to a similar classification. There are 2 modes. One is going from 60 to 65, and the other goes from 73 to 77. As we keep adding bins, we get more and more detail, and but all of them show roughly the same thing, that within the mid-70s we have the largest numbers of country at this time, and this is data for 2018. Remember that nothing like this is true in 1960s data. So there has been a significant upward shift in life expectancies, and this is not matched with the way that the GNPs have been increasing. So the process by which life expectancy has increased has nothing to do, or not much to do, with the process by which GNP has been increasing. Going from 10 to 20 bins, we have a more jagged pattern. Again, there is some sort of an evidence of bimodality, but now we have in fact 1, 2, 3, 4 modes, 4 little maximums. Pattern is becoming jagged, and it's not easy to see what is going on. Now this is a histogram with 40 bins. This is very hard to see what is going on. It's a paradox, because the more bins you have, the more information you have, but the less our eyes are able to understand the patterns in the data. This is with 100 bins. Now it's very jagged and it's hard to see what is going on. You can see that there is a large cluster somewhere towards the right. All the information in the small number of bins is contained in this one. That is, but The information is not easily accessible to our eye. As we increase the number of bins, ultimately we get very few points of data in each bin, and as we increase it to the limit, there will be only one data point in each bin. At this point, with 200 bins, it's a very jagged sort of a pattern. It's hard to see what this data is, what this histogram is telling us, even though the information in it is sufficient to reconstruct the 7 or 8 bins that we saw earlier. So it may be a question of having the experience to be able to look at these bins and to extract the information from them. To conclude this lecture, we make a few points. If you have small bin sizes, you have more information, but we cannot absorb this information visually. So a good bin size is one which balances the information, objective information available with our subjective capabilities to process that information, to look at the graph and to understand what it is telling us. Note that this information becomes visible after we make the graph. So there is no question of choosing an optimal bin size. These distributions that we see at different bin sizes, these are all models for the data, but there's no true model. There's no correct bin size. At each bin size, we get different kinds of understanding of the data. To understand what this data is telling us, we need to have a deeper understanding of the mortality rate which is being captured in this data. And we need to look at what are the causes of the changes in mortality. And this has to be done on a direct basis, that is, look at things which actually affect mortality instead of indirect causes. So these are some of the lessons that we come to from studying these histograms. And note that we have learned some things about the real world in terms of the relationship between GNP and life expectancies. And this is the object of analysis, to use data to learn about the real world. Much more information would be available if we did a deeper study of the mortality rates, and it is these mortality rates which are being captured in the life expectancy.